Well, I'm Curtis Hicks with Uneeda. This is our first go at doing one of these webinars. We hope to do a series of them to address very specific issues. I want to tell everybody that we really appreciate you taking the time to spend with us. I really hope everybody gets at least something out of this. For many of you, you've been doing this a very long time, and some of this may very well be redundant and things you already know. But again, we appreciate your participation and really appreciate you being here. So what we want to do today, and I'm going to start this, is our conversation today is going to be about common issues in wide belt sanding. It's a struggle that a lot of people have. Not everyone has the ability to go out and buy a brand new machine. Sometimes you have to work with what you've got. And one thing that Uneeda and Ecomon as a partnership has always done is tried to help people solve their problems with the equipment they have. It'd be great for everybody to run out and get brand new equipment, but sometimes just deal with what you've got. So that's our conversation today, is issues in wide belt sanding. And before we get started, you'll see down in red here, that's my email address, curtishicks@uneeda.com. And I want to get that out to everyone right away, because if you write that down or save it, after this is over with, any questions you might have that's in addition, if you want me to hook you up with our wide belt technician to talk to him, any of our sales engineers, if you reach out to me, I may not be able to answer your question, but I'll certainly find a solution for you and get somebody that can help you. So curtishicks@uneeda.com, and keep in mind, we have PDFs, training PDFs on almost any issue you can imagine. You're going to see one or two of them in here that's going to address wide belting specifically. But don't hesitate to ask. No matter what you think it might be, say, hey, I've got an issue with this. Do you happen to have any information on it? And we'll get it right back to you as quick as we can. So let's get started. The reason I'm showing this chart first, it's a maximum stock removal chart. And the reason that I'm putting this up first is because this is very critical to wide belt sanding. You have to keep in mind that wide belt sanding is simply doing math. You got a part that thick, you want it to get that thick, and you know how many heads you have to run it on. 3 heads on your wide belt sander, 2, maybe you got a drum sander, you got a couple of heads on that. So what you simply do is, if your wide belt machine runs at 25 feet a minute and you're needing to use an 80 grit on your first head, let's say you're gonna go 80, 120, 180. Well, you come over to 25 feet a minute and you come down, 25 thousandths is the most that grain is designed to take off. And the reason you see these numbers change based on feed speed is, if you think about it, if you slow your machine down, you're allowing that grain to come around and engage the workpiece more often. So therefore you're getting more stock removal. The faster you run your feed speed, the less times that grain is going to interact with the wood. So therefore you're diminishing how much stock removal you can take. Really pay close attention to these numbers, because if an 80 grit is capable of removing 25 thousandths and you try to take off 30, I'm not saying it won't do it. You certainly can, but you're going to start lowering the life of your belts. And the reason is, you're taking a grain that's that long and you're trying to drive it down that deep. And it's just not designed to do that, and you start having more issues. You'll notice at the bottom here, we talk about approximate depth of scratch. That never changes. An 80 grit on a 80 durometer or steel drum will take 18 thousandths. That's how deep that grain goes into the wood. No matter how fast you run your feed speed, that's always going to be the same. The feed speed again comes into play because you're not able to hit the part as much the faster you run it, so you're not getting as much stock removal. So this chart, we have it available in inches and millimeters. It's much nicer than what I'm able to put on here. And what we do with a lot of our customers, these are 8x11 sheets. And what we typically will do with some of our customers, we will have this printed on a magnetic sheet. We laminate it and you can stick it right on your machine. This is one piece of information that should be on every wide belt sanding machine, and everybody running that machine should understand how this chart works. So that's what I want to show you first, was the stock removal. So let's get into the issues people run into. I would say one of the #1 issues we run into with customers is chatter marks. Now, as you can see in this diagram, your sanding direction is going this way. these marks, they look a lot like shadows, and I'm sure most every one of you have seen chatter marks. Some people call them shadow marks, chatter, what have you. They run almost perpendicular to the workpiece. So it's almost always at a 90-degree angle. It's certainly always vertical, never horizontal. If it's horizontal, it's a whole nother issue. So chatter marks are what we're going to address first. And what I will say is on some of these slides, I'll spend more time than others. Some of these sanding issues you'll run into aren't as common, so I won't spend as much time on them. So chatter marks. Chatter marks are typically going to come from one of two things 90% of the time. Number one, it's either a belt joint or you got a machine issue. And so your first objective is to determine, is this a belt joint or is it a machine issue? So the very first thing I would do if I'm seeing chatter is I would check my joint. Now there's two types of joints. You have butt joints where you simply butt the material together, then you put a piece of tape under it. That actually is the type of joint we prefer to make. We also do lap joints as well. A lap joint is when you basically glue the one top of the paper onto the other. And what you do to get a zero tolerance there is you're scuffing and skiving the back so that you do get a zero tolerance. But the first thing you want to do if you're getting chatter is measure the belt where there is no joint, whatever that comes out to be. Compare that to what the measurement is at the joint. And you can have a thick joint whether it's a lap or tape. We do a good job of making tape joints because again, you're creating a channel in the back of that material to lay that tape in. So you should get a zero tolerance, maybe 1,000. But if you measure that joint and you got 3 or 4 thousandths thicker than the material, that chatter could very well be coming from the belt joint. The next most common issue with chatter is machine related, and it's typically bad bearings, faulty bearings. You'll see some other items listed on here. I'm not going to get too much into those, like a joint being too stiff, that's possible. Unbalanced brush roller, that can cause chatter, but I'm going to stick to the two most common causes: thick joint or bearings in a machine. Now there's an easy way to figure that out, and there's a hard way to figure that out. If you can adjust your feed speed on your machine, so let's say you're running 25 feet a minute and you want to find this out quickly. If you speed up or slow down your feed speed, you're going to quickly see if it's a belt joint problem or if it's a machine problem. And the reason is, if you're running 25 feet a minute and you slow that machine down to 20, that belt chatter is going to move. It's going to get closer because now the joint is engaging that part more often. Transversely, if you speed the speed up to say 35 feet a minute, suddenly that chatter is going to spread out. It's going to move because now you're not coming in contact with that part nearly as often. If you do that and that doesn't have any effect on the chatter, then you can almost bet you have a machine issue, because the machine issue is not going to change. No matter what you do with the feed speed, if you have a bad bearing and that drum is sitting there bouncing on top of that workpiece, doesn't matter how fast or slow you run it, that chatter is going to stay the same distance. And typically machine chatter is tighter than it is with belt chatter. Belt chatter tends to typically be around 1/4 inch or so, depending on the speed, whereas machine chatter tends to be much tighter. Now, let's say you can't adjust your feed speed. A lot of machines don't have that capability. There is a formula, 2 formulas that you would need to do that'll still give you an answer. And that's right here. So the first formula you would want to do is to determine your belt joint. So you take your belt length, and this is in millimeters because our friends at Ecomont sent me this, and I'm old school. I tend to use inches and feet and stuff like that. But so you take your belt length, however you want to measure it, times your conveyor speed, divided by your belt speed. That's going to give you a number. So just you calculate that and get your number. Then do this formula to calculate your contact roller. Dimension of your contact roll times pi, 3.14, times conveyor speed divided by belt speed. That's going to give you a number as well. So what you're going to do is you're going to get these two numbers, and whichever one is closest to the distance between these chatter marks is going to tell you whether it's a belt joint or whether it's a contact roll. If it's a belt joint, the odds are every belt in that box is probably going to be similar, because typically when you set up to run belts and make them, whatever issue one belt has, most in that run will have it because the machine's been set up and you set it up once and run the belts. biggest thing to do there is if you're getting a lot of belt chatter, you really need to contact your supplier, work with them to solve the issue. To be honest with you, from our standpoint as an abrasive manufacturer, even being the abrasive supplier, we would rather see that the issue for you is a belt, because that's easy for us to fix, your supplier to fix, compared to if you have bearing issues or possibly a drum that needs to be dressed or something like that. So, we're hoping for you that if you have chatter, it's from the belt. The next one is shiny lines or longitudinal. Let's say they're oscillating, narrow shiny lines with no ridges, which means they're not raised. Okay. Now, lots of things can cause that, and if you notice, they looked almost like stitches here. There's spaces between them, and these are kind of straight, but they are, moving a hair bit. These are definitely oscillating. So it could be small spots of the belt clogged from glue, resin, dust, lacquer, maybe the result of your air blower not working correctly. You may not even have air blowers. So for those of you who do, you want to check those. And to be honest with you, air blowers on most machines is the first thing to go out. I don't know why. Regardless of the brand, that's what we find to be the first thing on a machine to go out are the air blowers. So in that case, really the best thing to do is change the belt. You should see the issue go away. And what we always recommend, when you have issues, shut your machine down, open up the doors, get your belts out, and really do a good inspection of everything. Obviously, if you see glue build up on the belt, it's not hard to figure out that, hey, you know what, time to change the belt to get rid of these shiny lines. Now, something that I have here is static. And this is something I really want to talk a bit about because most people don't really understand it. Most people don't even realize it can be an issue. So we deal with static a lot. Now, static is typically not as big an issue, say, in the South where you have a lot of humidity. It's really when you'll see static issues rear their ugly head is when there's a weather change and suddenly it gets dry or cool. Now there's not a lot of humidity in the air and suddenly just dust wants to stick to everything. So these are actual pictures of static I chased for a week at a place. I hope you can see the pictures okay. They look like stitches. I've got them circled. And in this particular case, they're relatively straight. But you know what? I changed the belt on this, give it 10, 20 minutes. In this case, it was really bad. That static would jump all over the place. You might see some over here. It might pop up over there. Static is very strange in that sometimes it's raised. Sometimes it's not raised. It's flat. And a lot of people really scratch their heads trying to figure out what is going on. So to combat static, there's really one good way to do it. You need to ground your machine and you need to ground it directly to the bed near the last head. Now, a lot of machine manufacturers, God bless their souls, and they're great people and they definitely know what they're doing. But a lot of machine manufacturers will say, well, you don't need to ground your machine. It's grounded through the wiring or what have you. And that may be true, but look at this too. You have anti-static belts on your machine. Your conveyor is supposed to be an anti-static conveyor belt, but you're still getting static. The fact of the matter is you cannot ground your machine too much. If you could ground it in 4 or 5 different places, so be it. It's not going to hurt anything. But if you have static, the best thing to do to help try to eliminate it is ground the machine. Now, it is very critical to ground that machine to the machine bed, the actual right to the bed, not to a plate. So I'm showing you 2 pictures here. The one at the top is not correctly grounded. If you notice, this is a plate where they got some kind of roller. I think it was a hold down roller plate. So the hold down roller was fed into here, that's how it's in the machine. So this person had this machine, and this is a real life experience here. In fact, it might've been in Tijuana, Pascal. This was ground to a plate. Doesn't do anything at all. It's not helping discharge that static. That's the whole purpose of this wire, is to get that static to run through the wire into the ground instead of into your machine. So what we simply did here is we took it off that. Near the last head, we found us a spot where even though there's a plate here, there's a window that goes directly to the bed right by the last head in this case. Now, it's very critical to sand the paint. We probably didn't do as good a job here as we should have, but you kind of see this spot where we did grind it off. So you want to sand all the paint off so it's nice and shiny metal. Then you want to take a 3/8 inch thick or thicker copper wire. You can't get too thick. Be as thick as you can and make sure it's copper. And so you're going to attach that to the bolt there and have it nice and tight up against that bed. Then you're going to take a grounding rod. We prefer copper. It's absolutely the best way to get that static charge out of your machine. But listen, even a piece of rebar will work. Anything is better than nothing. You take that and you drive it through your concrete, down through the floor, about 5 or 6 feet into the ground. Now, be careful because in some places, you know, people have heating under the floor, things like that. You really need to make sure you understand how your building was built and whether you have the capability to do this. In most cases, you can. You need to ground that rod 5 to 6 feet. It definitely needs to get through the fill dirt. It's not nearly as effective if it's not into the natural ground. So that is the key here. And in this case, this is ground near the platen on this particular machine. I remember it. But again, if you ground every head, it's okay. You can't ground it too much. But believe it or not, a lot of people don't know this and they don't understand it. We have literally seen static disappear. Now, the way you check for static, if you happen to have a static meter, which our technician carries one, a few of our salespeople have them, they're not a cheap device, $500 meter. But obviously for what we do, it's critical that we have it. But even if you don't have a meter and you don't want to spend that money, that's fine. If you're seeing these weird lines, just go ahead and ground your machine. And it's not even expensive. You're talking probably about a $60 fix here that can really reap you a lot of benefits. So that's static. Shiny lines that are longitudinal or unbroken, oscillating lines, no narrow ridges, which means they're flat. And one thing I want to point out too in this picture, you notice that this is oscillating, it's curved. Anytime you see a line that oscillates, that means that it's definitely coming from a belt. That's not a machine issue because the belt's actually in your machine moving back and forth. So that's why you get this look in the line. And we'll talk a minute about some other things you'll see where the line is straight, and that's always machine related, and we'll talk about that in a second. But so shiny lines, again, you might have narrow parts going through the machine that's clogged up your belt in a certain area, may have even killed the grain in an area that's made it where it's kind of leaving a shiny spot. Could be the result, again, of the jet blower not doing cleaning properly. And so on those number one issues there, you want to change your belt, check your air blower, install a second air blower if you've got money to spend. Never can have too much air blowing going on to clean your belts. But number two, and this is one I really want to talk more about, is check your graphite and your felt on your platen, but most importantly, your graphite. We are very surprised how many places we go and they just run graphite and don't realize that it's worn out. They're getting lines. And let me tell you, if I had a hair, I don't, but I've seen hair get under graphite before. Just a hair, which is so minute and small. Every part that went through that machine where that hair was under the graphite bled right through to the part, and you could see that line. Anything that's defective on your graphite, in many cases, because this is on a platen, will transfer right through and show up as that look on your part. So here's our technician, Tony Bentley. On the right, you'll see this picture. This mark here, this smudge, this indentation in this graphite was causing a mark, part after part after part. And we're not saying that in every case you need to change your graphite. Look how new this is. That's a beautiful piece of graphite. It's almost brand new. We're not, look, we understand you got to keep your costs down. So what you see Tony doing here on the left took maybe 5 minutes. He got a piece of 150 grit sandpaper and he sanded that smudge out. You can even take a DA sander and put a 180 grit, 150, 180 grit disc on it, nice and easily sand across that graphite, get rid of the lines, and put it back in, and you'll see that your defect has cleaned up. We do this all the time. And again, anytime you see an issue, one of the first things you want to check is your graphite, no matter what the issue is. So many problems can be solved simply by changing graphite or repairing it like you see here. So graphite is a very key aspect in wide belt sanding on the platen. And you won't see graphite anywhere but a platen. Bad surface, so what you're seeing here are some thick, wide lines, oscillating scratch pattern, shiny. Again, you're gonna most likely see this on your belt. It's probably clogged, you might have glue on it, starting to look, you know, burnt a little bit in that spot. Also, too big a stock removal or too high sanding pressure can cause this issue. Now, we are very adamant about belt tensions and sanding pressure. Now, you know, not everybody's probably using our belts, and there's lots of good sandpaper out there. Our brand is Ecomont. That's the only brand of coated abrasives that we sell for wide belt sanding, and there's a very big reason for it. It's because of the fracturing of the grain and the way they're designed. What happens is you start out with a very sharp grain, and as you're running it, that grain is going to naturally crack and resharpen to more sharp tips again. Now, some sandpaper starts out sharp, it cracks and gets dull, and that can certainly cause an issue. But belt tension to us is very important. We recommend that you run under as light a belt tension as you possibly can. Now, some older machines use air pressure, only have one air pressure adjustment, and it handles your tracking and your belt tension. That doesn't leave you as much opportunity to adjust that. For us, we want to run under as light a belt pressure as possible, about 3 bars, so 40, 50 PSI. You know, you may have to adjust a little higher. And I wouldn't really trust your gauges. What we do, we open up a machine, we don't even look at gauges. We reach in and squeeze. Like on a platen, you grab both sides of that and squeeze, and that cylinder at the top should move relatively easy. If it's a drum with a drum and an idler roller, you can put your hand inside the belt and pull it out. But if you put your hands in there and that cylinder won't move at all and it's so tight, that could certainly cause defects. Looks like we've got a question here. Can you email this PowerPoint to us, Peter Smith? Absolutely, Peter. If you will, just send me your email address and I will be happy to send that to you. Tom's asking, can a bad graphite pad cause chatter marks? Typically, Tom, graphite is not going to usually cause the chatter. What will typically happen is usually you don't get a lot of chatter off a platen to begin with, because you know it's soft enough that if you got a thick joint, it'll kind of conform into there. But what's happening is your chatter is usually coming from your first or second head, especially a metal drum or a hard rubber drum. So what's happening is that the problem is the chatter is probably in the part, and the platen is just the stock removal on that last head is just not enough to get it out. The chatter is too deep. Because if you're sanding with a 180-220, you're not taking but a couple of thou off, and it's just not getting in deep enough to get rid of that chatter. And the way to figure out where the chatter is coming from is you can run head by head, shut all the other heads off, run the first head first, then the second, and your chatter is going to show up on which head it's coming from. So that right there tells you where to start looking to solve your problem. But unfortunately, you know, it's the chatter's not usually, graphite's not really going to help much with that. Okay, and so keep an eye on your graphite for bad surfaces. And again, the belt tension is very important. A lot of people really jack it up. They think they're helping the situation, makes the belt track better or whatever, but tension can be an issue. So you want to be able to reach in and get a nice, easy squeeze on that and have that cylinder move up and down for you. So actions to take: decrease your sanding pressure. Of course, you're getting these kind of marks, change your belt. Typically, you've got a burnt spot or something, and that's what's causing that. Take a look at your graphite. Okay. Okay, ridges. These are raised lines. So longitudinal, short, and narrow oscillating ridges, sometimes only following the oscillation in one direction. You know, that could come from a lot of different things. Too big a stock removal can sometimes cause this. Poor dust extraction, and what happens there, if you don't have good dust extraction, that you'll get buildup of dust in certain areas that's causing that skipping look. And what's happening is the reason that line is raised, if it's due to dust, is that dust has piled up so much that you're not getting any cut from that piece of the grain. So the grains around it are cutting, and that one is not, so it leaves a raised part of the wood. So sometimes you want to decrease your sanding pressure, you may need to change the belt. Longitudinal, unbroken, narrow oscillating ridges. This is best known to everybody, and we've all experienced this as a raised line. This is next to chatter, is probably the second biggest problem we run into, static probably being the third. This is quite simple. If you see this line, the abrasive grain has been damaged by some type of foreign particle in the workpiece, or which typically when we see raised lines, at least in the States, because a lot of people will pin their stiles and rails together, their doors together, so that it gets the glue. You know, you do that until the glue will set up and hold the door together. What happens is sometimes those nail guns are pinning it a little deep, and you may not get it until the second or third head, but eventually it's exposing that nail or that pin, and then that's breaking the grain on your belt. And I don't care what you do, there's no solution for that other than changing your belt. Unfortunately, once that grain is broken, you will always get a raised area, because now you have no grain there to cut it down. So you're cutting all the wood down beside that area, but you're leaving that one high spot. What we find in our industry, typically the backs of doors are not as critical for raised lines. People will accept a certain amount of that. When you start looking at the face of a door, it's a big defect that's a problem. Now, one thing we are starting to see is more and more companies are trying to get away from pinning if they can. You know, you just have to really get ahead of it and have good glue racks. And, you know, pins are only there for the purpose of allowing the glue to set up, but people might want to run their process before it's really cured well. So if you can do that and just get away from pins, it's good. There are composite pins now that are sandable. You know, they're not bad. They're expensive as they can be. That's one problem. And then sometimes too, like hickory, you can't pin very well with that stuff with hickory. It's just too hard. But again, just keep an eye on your pins and try to really, you know, do a good job of keeping your guns in good condition where you don't pin too deep. Okay, longitudinal straight lines not oscillating, 99.999% of the time you have a machine issue. That's not coming from sandpaper. Sandpaper will always oscillate. So the contact roller could be damaged. That could cause a straight line. The graphite could be damaged. I don't really see that typically as an issue that would most often leave a straight line. And one thing is, on a lot of machines, you know, in order to hold the wood down, you're either using a roller, or some machines have shoes in them. They're, you know, I'm sure you've seen them, thick metal, wide metal shoes that are basically about level with the sanding head. And over time, what will happen a lot of times is those shoes will get a little burr on it, a little burr of metal, and that will put that line into your machine. Or actually, I take that back. These are raised lines. If it's a shoe, and we'll talk about it in a minute, it will actually be a depressed line because it's cutting into the wood. So if you're seeing these lines from that, you really need to check your contact roller out, and you know, odds are something's going on with that. Longitudinal short oscillating scratches. Again, that's going to be coming from a belt. Coarse grains in the sanding belt. Now what that means is this, and I have to take my hat off to Ecomont, and I've been with the company 18 years, and I can honestly say I've never seen what they're saying about coarse grains is called a wild grain. And if I understand it correctly, the wild grain gets into your belts because of the cleaning process of the makers. So in other words, let's say you're using a 180 grit belt, and they ran a batch of 120 grit on the maker, where the stuff's actually coated to the paper, and there's some 120s left in there. So if you can imagine what's going on is you've got this belt and you've got your 180 grit grains, and in some areas in there you got a much longer grain, a big bolder, more aggressive grain in there. So what's happening there is that is causing a different scratch depth. Now sometimes that works itself out, because as those grains crack and break down, they'll even out. A lot of times when you start up your machine, even wild grain, when you start staining that, you'll see dark and light scratches in your finish. Well, those darker scratches are coming because you got some wild grain in your belts. So you got some areas of your belt that's sanding a little deeper than, say, the 180. Let's say you got some 120. It's getting a little deeper in there. So obviously when you stain that, you're getting a different color. It's going to be darker than the 180 grit would be. So not a lot you can do about that. If you get a lot of it, you just really need to evaluate the sandpaper you're using. Like I said, there's lots of good manufacturers out there. There's also some out there that don't do as good a job as they should of keeping wild grain out of the belts. There could be an impurity in the joint. I've even seen where, you know, you'll get little pieces of shavings or metal from that was in the wood that can get caught up in there that can cause these ridges as well. Unfortunately, a lot of times the solution to that is changing the sanding belt. You check the joint, the surface of the belt. You know, take a good inspection of everything to see if anything's lodged in it that could be causing that. Scratches or grooves, longitudinal, short oscillating scratches. Piece of wood could be stuck in the pad or a ridge of the graphite. What we see a lot of times is, you know, you keep getting this weird line and you can't figure it out. And we've even noticed sometimes when people have a belt bust in a machine, sometimes little parts of that belt, they didn't get cleaned out well, may be stuck up in the dust vent. And you can't tell it until you really inspect it well, but it may be rubbing against your part as it's coming through that can cause some of these lines. So it could be dust or resin buildup causing ridges on your pressure beams, your pressure rollers. And what that is they're talking about your hold down rollers. So machines that don't have shoes will have a hold down roller. Let's say this is your drum. Oh, wow, you can't see that because it's yellow, huh? It's not good either. Let's say that's your drum. Here's your hold down roller. Hold down rollers should always be about 20 thousandths below the drum because they're spring loaded. So as you feed it, this is holding your part down. It's going to kind of come up. But if this hold down roller has a lot of glue or buildup on it, it can certainly cause scratches or grooves in your workpiece. So with that, you just really need to clean your rollers off. Make sure they're in good condition. A lot of people don't pay a lot of attention to their hold down rollers and shoes. Most people don't have the equipment we do. You know, when our technician comes in, he's got digital indicators and he can really diagnose your machine because he's got all the equipment to do it. Well, that stuff's expensive. It's, you know, not everybody's going to have that ability. So what they tend to do is run sticks on each side of their machine to level the heads because they can do that. But they don't tend to pay attention to hold down rollers and shoes, and they are very critical to the process. Hold down rollers, if you don't have them in the right position, sometimes you'll get sniping where it cuts the top edge of your door coming in where the back one's fine, the top one, you're like, why is this thing sniping? Well, it's because of what's happening. Your hold down roller is not keeping that part down and it's kicking up into your belt, shaving off that top edge, then it flattens out, the rest of it looks fine. So pay attention to your hold down rollers. Longitudinal burning marks, that's a pretty simple one. Could have heavy clogging on the belt, sanding belt. You'll be able to see this pretty much as soon as you take your belt off and inspect it. It's typically a very dark line, just like you saw in the picture of the wood. It's going to be on your belt as well. Once burning starts, there is no solution other than to change your belt. You know, there's just no getting around that. Could be that you don't have enough cutting power in the sanding belt because of high sanding pressure is too much. You get too much removal. And possibly the grain's lost its sharpness in that area. Sometimes if you run a thick part through one side of the machine that, you know, it's thinner on the other sides, it can actually, you know, kill that grain, so to speak. Like you don't have a sharp cut anymore and it can start leaving burn marks because you're creating a lot of friction. It can also leave other types of lines. So the actions on that is obviously change your sanding belt. If you don't feel like you're getting enough cut, then go to a bit coarser belt. Repair any damage that you find on any of the components in there. One of them on here says there could be a piece of wood stuck in the pad. We've certainly seen that. You know, you just got to do a real good inspection of the inside of your machine to make sure everything is clean. Got a couple of questions here. Let's see if there's anything. Nope, sorry, those are old. We'll move on. Okay. Now, the next part of this presentation is going to be about veneer, and then we get into a little bit more about some belt issues, and we'll get through the veneer stuff pretty quick because most everyone that's running veneer and running it a lot, they're using a segmented platen. They're not using a regular, you know, machine that has drums and a solid bar platen. So if you're not familiar with a segmented platen, just think of a piano. So instead of having a solid platen bar, you've got a bunch of little bitty platens running all the way across this bar. And then what happens is you feed the wood into the machine and you're going to see these little rollers and they're about the same width as the little platens on the platen bar. Well, that's like a brain, it's a reader bar. So you put a piece of veneer in, let's say this side over here is thinner than the side on the right-hand side. Well, that machine is so smart and it's all programmable. It's like a brain in there, and it says, hey, it's telling the platen, hey, listen, man, this side of the veneer is thinner than this side. So what's going to happen, all these little platens over here, just like a piano, they do just like that. They're going to fire down more on this side than the ones over here, because the brain has told them you can't reach this piece the way this one can because it's thicker over here. So those little platens are going to fire down based upon how thick that veneer is on that side. Now, if you're getting a sand through in the middle of the workpiece on veneer, the workpiece could be cupped. And believe me, more than ever, people have gone to thinner veneers, and unfortunately, a lot of people have gone to less expensive substrates to put that veneer on. But if you get a cup in that workpiece, obviously it's raised higher there. So what's happening with that sand through is taking that off at that peak. Now, segmented platens are typically can handle that better than others, but sometimes there's just no getting around it. If it's warped enough, it can cause that problem. The sanding pad is not sensitive enough. You know, segmented platens can be a real problem. We're pretty decent at working with segmented platens, but it's a completely different thing. It's not a matter of coming in with a tool and leveling something. Like if you have an issue with drums, platens, our tech can come in there and get everything lined up. You get into segmented platens, it's a lot of programming. There's a lot of, you got to adjust how it raises and falls and what kind of timing is between that raise and fall. We always will try to help. I'm sure your other suppliers try to help, but in the end, a lot of times you may have to get with the machine manufacturer who really understands the programming of that machine. We do have some people with our company that are very good at that, relatively good at, good at it, and we'd be happy to always involve them and answer your questions for you if they can help. Doesn't even necessarily have to be, you know, in the plant. A lot of times over the phone, they can give you some good advice. Let's see if we had a question come up. Okay. In this case, you gotta, if you got a lot of cupping in the wood, you just gotta really look at your raw material, and just keep in mind, sometimes, you know, I understand the desire to get substrates and veneers that are cheaper, but sometimes, unfortunately, what it costs you in repairs and stuff is just not worth the cost savings. It also goes on to talk a little bit about the temperature and the air humidity in a factory. That certainly can affect things, but there's certain things you just don't have control over. You know, some plants in the South aren't air conditioned, and you know, you get a lot of humidity, and that's not going to change. So just kind of have to work with it and try to get around that as an issue. Use another sanding machine. That's always a good option, huh, if you got one. And always try to find the fault and correct it. Again, sometimes that may take actually getting back with your machine manufacturer and getting somebody that really focuses specifically on segmented machines. Okay, now if the veneer is sanded through on one side of the workpiece, and like in this picture, again, that is all about getting those segmented platens, getting your fall and rise on the edges correct. So what's happening here is it's not reading it well, and it's probably dropping that left side of that, in this particular case, it's dropping those little platens down too much on that side. And so it's a machine adjustment, and that's usually done on the control board, the PLC. Again, unequal work thickness of the workpiece could be the problem. If it's much thicker on one side than the other, you know, it certainly could cut that edge off. That will definitely happen if you don't have a segmented platen. If you put a piece that's really thin on one side compared to the other on a regular machine, it's definitely going to cut through on the high side. The pad is not in level. That goes back more to not a segmented platen, but a regular one. So if your platen is sitting in here like this, you got to level it up, or it's going to constantly sand harder on one side than the other. The conveyor table is not in level. That can be a really big issue. So what that means is, you know, when these machines are built, that conveyor table is level, and typically that thing can get jacked to the side like this. Now that's a big problem because that's usually jack screws. We don't even let our technicians work on jack screws. That's a very complicated process, and you're going to need to get somebody that can tear that machine apart and fix that. You can check for that if you get under your machine. There's usually 4 jack screws. There's always 4 jack screws, and you can measure them to see if one is they should be exactly the same distance from the bottom to the top of your bed. Could be the wrong adjustment of the edge compensation and electronic pad. That's what I was talking about earlier, where you got it firing too hard with too much pressure. The graphite is worn unevenly. That can certainly be an issue. Again, like we said earlier, always check your graphite. If it's worn, what happens in a lot of plants, they tend to run parts in one spot more than others. So let's say you got someone feeding it and then someone stacking it off, and the person stacking it off is on this side of the machine. They'll tend to run more down that side, keeps him or her from having to reach over and pull parts. But what happens with that is it starts wearing everything out unevenly. It wears your graphite out unevenly. It starts making your conveyor belt thinner on one side than the other, which starts a whole nother group of issues and causes these kind of problems. It's really best to always try to stagger your parts evenly across the machine. It'll certainly help with some of these issues. We pop up here real quick, like we might have a question. Okay, the question is, what is the difference between static and air bubble under the veneer when sanding bad glue? That's a tough question. I mean, static's just a entity all of itself, and static strictly comes from the air temperature, or rather the air around you. It's very dry. Air bubble under the veneer when sanding bad glue, I may have to do a little more research for you on that one, Shakri. It's not something I've typically run into a lot. I'm not exactly sure. I would think a lot of that has to do with how the glue is spread. But I will keep these questions, and I promise you I will do a little research on that and try to get back to you more on that. If anybody does that's listening to this have any answers for that, again, the question is, what's the difference between static and air bubble under the veneer when sanding bad glue? If you have an answer for him, for Shakri, please send it to me, and I will make sure I get it to them. And I apologize to anybody if I can't answer your question on this seminar. I'm not going to tell you something that's wrong, and I don't give you an answer if I don't know it. It won't do you any good. So let's go to the next one here. Again, the veneer is sanded through on both sides of the workpiece. This typically, again, is going back to your segmented platens, and in this case, they're firing too hard on both sides of this part. So the workpiece cups too much. Again, it could be cut really in the center, or I'm sorry, it'd be the other way. These, in this case, maybe the edges are higher than the center. So it's obviously going to cut the edges off deeper than it would the middle, and it's going to sand through in this case. The sanding pad's not sensitive enough. Again, that's programming, making sure your reader bars, and also the little readers, you know, the round segments coming in that read the veneer, if they get glue and stuff on them, that can be a big issue too, because now it's not reading correctly. So it's very important to always check all of these things out. And on those little reader bars, you got on those little wheels, you're going to have a spring. Sometimes that spring will get caught, you know, and it's very critical on segmented platens to really inspect your machine well and keep things up to speed and replaced. It's never going to fix itself if you got a stretched spring or a bad spring, or if you got glue on a roller. It's never going to give you a good result until it's repaired. Use raw material that's more plain. In other words, don't, you know, again, try to use a material that's nice and flat. Temperature and air humidity in the factory is not correct and stable enough. Now, some factories certainly pump humidity into their facilities, but to fight these issues, that's definitely an option. Again, we always keep our smaller customers in mind that might not necessarily have those resources. So you always have to, in those cases, try to find some other solution. Use the total width of the machine to avoid some of these things happening. As we mentioned before, make sure you spread those parts out across the machine. The veneer is sanded through on the front edge. Now, when you start talking about segmented platens, you start talking about rise and fall. So what may be happening in this case, that machine is programmed to take that once it comes through. It tells that the very first part of it when to drop those platens, the segments, and maybe it's dropping a little too soon, a little too far. Again, that's all programming. That's what you really need to take a look at. Wrong setting of the pad, technical error in the pad or fault. I know a lot of these answers are redundant because they're pretty much always the same types of issues on segmented platens. The veneer is sanded through on the back edge, exactly the same thing, just the other way. In this case, they didn't pull the segments up maybe soon enough, or again, there may be too much pressure on that back end when it's coming through on the segments. Now this one, veneer is sanded through the inner edges of the frame detail. But I also want to address this with regards to, say, face frames. A lot of machines have a vacuum bed. Vacuum beds are great for holding solid pieces down. But if you are running face frames, you're going to see down at the bottom, and I'm addressing this because if people run into this a lot, it looks like a football effect. Because what's happening is if you got face frames, you got big spaces that are open. You got lots of little stiles and rails to build your frame. You got a lot of space in there. And what's happening, it's holding that, it's pulling that the wood down, but then it creates almost it kind of creates a bend in that. So it's sanding harder in certain places. So vacuum beds are great when you got solid parts, but if you start having a lot of doors with big windows in them, the best thing to do is cut that vacuum bed off, or you're going to see a lot of footballing effect where you're going to get deeper sand throughs in parts of that door. In this one, they're talking about more back to the veneer unequal thickness of the workpiece. Again, if it's bowed in the middle, it's going to cut through compared to if it's flat. The vacuum in the conveyor table is too strong. A lot of vacuums can be adjusted because it's pulling that down and sanding harder in certain places. Maybe you can alleviate some of the vacuum. Now, vacuum's important because that is what, in a lot of these more expensive machines, is what's holding that part down. You know, and it's very critical because like on a little drawer front, you might not have a roller to hit it to hold it down. So sometimes that vacuum bed really does a nice job of helping you achieve keeping that part nice and flat and getting through the machine. Check the thickness of the workpiece, and again, switch off the vacuum, especially on face frames. I would never run the vacuum on a face frame. Okay, we're going to get to a little bit of things about actual belt issues. We do see issues sometimes of the Y belt creasing or folding in the middle. Typically, there's going to be one or two things to address with this. Number one, again, belt tension is critical. It's usually the primary cause of this. If you've got the belt tension too high, that belt's not running across that roller, across your drums effectively, and it can tend to make it roll up over on itself. It's almost like it sticks and rolls over. Sometimes not having enough belt tension can cause that, but it's typically due to too much belt tension. Now, one thing that happens a lot, we'll see this sometimes, I shouldn't say a lot. We see situations sometimes where this comes and goes and everybody's scratching their head like, what's going on? But we found in some cases where you might have a machine that has a little bit of an air leak. So what's happening is you've engaged the head, and then over a little bit of time, you start losing air pressure. And that can certainly, once it gets below a certain point, that belt loosens up, it can certainly cause it to roll on top of itself. So you could have too high sanding pressure, incorrect oscillation, too fast in one direction in both directions. So you do need that oscillation to be very consistent. If it's doing this and then coming back slow, it can cause that belt to grab and roll up on itself. But I would keep in mind most times in this case, it's too much belt tension or you're losing some belt tension at some point through this. Again, unequal belt tension when the machine has two cylinders on each unit for the belt tension. Let's say one of them has more, you may have two cylinders instead of one. A lot of machines have one cylinder that engages that head. Sometimes there's two. Well, if this one is not at the same belt tension, then it's going to obviously get more tension here than here, and it can certainly cause a belt to roll up on itself. Belt breaking in the material or the joint. That is certainly an issue that a lot of people have, and it can be caused by a lot of things. A tear on the edge of the belt, I'm going to show you a really cool secret here in a minute how to fix that. But a tear at the edge of the belt has arisen when the belt was put in the machine or under previous handling. Improper storage of the sanding belt, they become too conical or cone shaped. Now what that means is this, especially paper, and we recommend at our company to go to paper on a Y belt machine as soon as you can, if your machine will run paper. You may get some older machines that just can't handle paper, they don't track well enough. But from our standpoint, we only put cloth on a head if it's absolutely necessary. Let's say you're building a 5-piece door and your stiles and rails are not real level. So you got a 20 thousandths difference between your stile and rail. You probably want cloth to hit that, to cut it down. It may be too much of an impact for the paper and may bust it. But from our standpoint, you absolutely always get a much better finish out of paper than cloth. If you take cloth even in a 220 grit and you hold that door up to the light, I don't care if you go 220, go however fine you want, you're going to see a little bit of a railroad mark running through that part. Not to say that it's even going to show up in your finish, but you look at the light and it's there. And the reason that is there is because of the weave of the backing. That's what's causing that mark. Well, paper is, when you coat abrasives to paper, it's nice and flat and pressed flat and just gives you a beautiful finish compared to cloth. But the problem with paper is you have to store it correctly. If you take paper and you set it down on the concrete, you know, you set it down and that's where you're leaving your belts all day, concrete is full of water. I mean, absolutely has moisture in it all the time. And what's happening, that belt, that paper belt is acting like a sponge. It's just sucking that water up. So think about this. You set it down, it's going to swell up more on one end than the other because the bottom part of that paper is the one being exposed to the concrete and sucking up the water. So what's happening now is you got one side of your belt that's actually swollen bigger than the other. Now, a lot of times you put that belt on the machine, after a while, you'll probably even hear it flapping. After a while, it'll dissipate that water if you're lucky, and you can run fine. But what will typically happen, because it's swollen on one side, it won't track. And it's shooting that paper belt across your machine, and you guys know what happens then. Once it hits something over there, it just blows up. Cloth, obviously, you got a better chance of not busting cloth like that because it's more durable and can take the impact. Paper is very sensitive. The photo cell is very important. So, you know, as these belts are tracking, it runs over and there's an eye that reads the belt, and that's what kicks it back to the other direction, and then it hits another eye and comes back. There's always, we find a lot of times that the photo cell, the sensors are bad and need to be fixed. Now, a lot of times, especially if you don't have good dust extraction or you do have static issues, sometimes just keep an eye on your sensors and the eye. There'll be a little eye on there. Wipe that off every now and again, blow it off. If that eye gets dust on it, it can absolutely cause tracking problems. And once you can't track the belt, it's going to run over and blow up. The backing's not strong enough for the present sanding operation. That could be the case. That's not really a big issue that we run into. The joint's not strong enough. Again, we just don't really run into that issue much. I want to show you how to repair the torn edge of a belt. This can save you a lot of money. And I have to be honest with you, I've always assumed people knew this, but I can't assume anything. People could have been in this business 20 years and not realize what's going on with their paper belts. So a lot of times when people are hanging their paper belts, it's very sensitive material. They may push it all the way up onto the rack and put that little bitty cut in it just from handling it. We see this all the time. Now, that's just a little bit of a tear. When you put that on the machine, it's going to run for a little while, but it's not going to be long before that tear takes off and just blows up in the machine. Now, this is I told you earlier, if it were me on my machine, I would have a placard. And what we do, again, we tend to, for a lot of our customers, or what a lot of our customers do is we send them a PDF, they print it. You go to Staples, they have 8x11 magnetic sheets that you can print on, run right through my printer here at my house. And then we laminate that and you stick it right to the machine. This is the other piece of paper, other document I would have on every machine. And I would tell everybody to look at this and to understand how to do it, because this is a simple fix. What you see here first is the little torn edge. So what we're doing here, we're taking a pair of scissors, utility knife, you know, whatever you have to work. I've even seen people take a really sharp putty knife, but obviously scissors or utility knife's better. So what we're simply doing is cutting a half moon. It's got to be a half moon. You come here and you got to get below the tear. The tear stops here, so you see I'm going to come below that. And I cut this piece out. It left it like this. You can run that belt until the life of that belt is gone. No problem at all. I've even seen, we did a test once, and they weren't using that much of the belt, unfortunately, because the machine was kind of jacked up. We had a section taken out. I bet it was a foot into the belt, and it still tracked. The reading eye still caught it, and we ran that belt like that for all day long. You know, it's not recommended. Usually when you run into this, it's little sections. I mean, just little areas. But this will save people a lot of money. If you don't know this, start doing it, and you'll see your abrasive costs go down, at least with regard to belts tracking off and busting. Again, we have this PDF. If you want it, we'll be happy to send it to you. Okay, the belt is flapping. You know what? I'm sure a lot of you have seen this. You see it's nice and tensioned over here, and over here it's doing this. Improper storage of sanding belts is the #1 cause of that. Again, you're putting paper on the floor, one side of that belt sucking up the water, and all of a sudden you're getting a floppy belt on the machine. High air humidity variations, that can certainly happen. We have a product called ARKF02, and we have a product called ECA 1000, are two of our #1 selling paper belts. We have one account in particular that is, their plant was basically built almost on top of a lake, and they're in a very southern area of the country, and there are times of the year the humidity is just, you can see it in the air. So it's weird, at those times of the year, they like the blue belt, the ECA 1000, because of the longevity. It's a great product. ARKF02 is an awesome product, especially for finish, one of my favorite products for finish. But the thing is, there's a difference in those belts. The way that we do the anti-static in those belts is different. And what we've come to find is the ARKF02, because the anti-static properties are in the resins, they don't cup very much. You can put in lots of humidity and it just doesn't soak up the water and cup like the ECA 1000 will, because the ECA 1000 has a different process where the anti-static is put in the back of the belt. Now, both properties work fine, but we found in this case that because of the way the anti-static is done, that in a very humid environment, ARKFO tends to just handle the moisture better. So believe it or not, this customer, during certain times of the year, we switch them to ARKFO2 till the humidity dies down and goes away, and then they go back to the blue belts. So, there's always solutions if you look for them sometimes. So high air humidity variations, improperly made joint. That is can definitely be a problem, is having an incorrect joint. And even on, we'll get to tracking in a minute, talk about that, but that has a lot to do sometimes with how the belt is built. So if you can, store the belts in a dry place on wood panel or board or a hanging rack. We always recommend hanging your belts. Control the variation of the air humidity if you can in a storeroom. And the reason is, like, I never understood this. It took me a while to get my arms around it. Sometimes I'm not the smartest guy in the world. I'm like, why would you want to put your belts in a nice humidity controlled area when you're going to pull them out and put them in humidity? But the reason is, if you keep that belt in a lot of people will build a box, especially in high humid areas. They hang the belts in this box and they have a dehumidifier in there to keep them dry. And then what they do is they don't take that belt out till it's time to put it on the machine. And that way you're taking a nice dry belt, you're putting it on the machine. And as soon as you start running it, humidity is not a problem because any water that's in it's going to dissipate. But if you've got them sitting out in that humidity, it's a problem from the beginning because you put it on, it's just full of water. It tends to cause it, problems. It could be swollen on one side or the other that cause the flapping, cause them not to track. And then again, the last thing down there is inform your supplier. Always involve your supplier in your issues. That's what they're there for. Most companies like ours have people that can help you with these issues if you inform them and help you troubleshoot them. The sanding belts have a tendency of cupping. It's where they're folding out. And again, that's almost always humidity. We've already covered those areas. Better storage, if you can put them store them in a area where you keep them dry and then, quickly get them on the machine and get it running will help. Don't set them on the floor. And then that's really your only options there. Try to control the variations of the air humidity if you can. The lifetime of the belt is short. We hear that sometimes. That's a very relative thing. There are reasons for that sometimes. If you're sanding with too much pressure, it's going to obviously, kill that grain quicker. Because what happens is, the reason we like to have light belt tension to where when you squeeze it, that cylinder gives. You got to think when you're feeding a piece into the machine, there's quite a bit of impact on that drum coming in. You hit it, and if you've got nice light belt tension, it gives that drum a little bit of movement. So instead of coming in and just bam, hitting something that just won't move, you're hitting something that gives you a little bit of cushion there and it moves a little bit. So it's going to help lengthen the life of the belt. Bad dust extraction, and listen, we see this all the time. Our technician carries a dust extraction meter. It's very nice. It's Bluetooth to his phone. And there's nothing in our lives that make us feel worse than telling somebody that their dust extraction system just isn't very good, because you're telling a person that they got to go out and spend a ton of money typically to fix that. And that's not always a solution for people. You could have a bad air jet blower cleaning system. Wrong grip combination can certainly cause short belt life. Again, some people, they do the math. You got to do the math. You got to figure out how much stock removal you can get from your abrasive setup. it's better to have to make 2 passes than to try to force everything through one. In the end, you're not helping yourself. You're going to affect your finish, and you're going to affect your belt life. Take the time to do another pass. I know it's not the best solution for people. They want to get this stuff done quickly, but it's very important not to overtax your grit sequence and your grits. Wrong type of sanding belt, that could certainly be an issue. Like I mentioned before, if your stiles and rails really aren't very even and you got to cut that step down, you're better sometimes to do cloth. Paper's not going to hold up. Looks like we had a question. Let me see here real quick. Let's see. What would be an incorrect grit sequence sanding for a 2-headed wide belt sander? Well, first of all, again, you want to take the width of your part. Let's say a lot of people want to start at whatever, their parts come in at 805, 806, whatever. They want to get down, you know, kind of the magic number a lot of times on doors is 750, that's a 3/4 inch door. Do your math. Okay, use that grit chart that we sent and do your math. And that's going to tell you what your capability is with those 2 heads. Now, an incorrect grit sequence with a 2-head machine, and this is the rule of thumb for everybody, whether it's a 2-head, 4-head, 5-head, whatever you got, never skip more than 1 grit. We see that as a big issue a lot of times, because let's say you only have a 2-head machine and you do need the stock removal from the 80 grit, and let's say you're doing oak. You can even finish oak at 150. I mean, it leaves a beautiful finish a lot of times. So you really don't want to make another pass. You don't want to have to change the belts on that 2-head machine. So you may be going 80, skipping 100, skipping 120, and finishing 150. Unfortunately, the rule of thumb is because of the length of these grains, how deep they cut, you can't skip more than 1 grit. Most all the time, if you do that, you're going to see the bleed through from the first grit. And I'll tell you a quick process to check on your setup, whether you have 1-head, 2-head, whether you have 2-head, 3-head, whatever it is. If you take a board, turn it to an angle to the right, cut off all your heads except the first head, run that through. It's going to put scratches in it, okay? Now, take that part and turn it the other way, turn the first head off, turn your second head on. Run that through. If you don't see those lines all nice and on the second one, just straight, you know, angled lines. If you see like a checkerboard, what's happened is you don't have enough stock removal from that second head to remove the first scratch. You throw some stain on there, it'll really jump out to you. So one of 2 things are happening there. Either you need to bring that second head down to engage that part more to get rid of the first scratch, or maybe you need to bring the first head up to take off some of the stock removal, or perhaps you're skipping too many grits. But there's not, Chris, the question is from Chris Kane, and thank you for the question, Chris. As long as you're not skipping a grit, I wouldn't say it's an incorrect sequence unless you're trying to take off more stock than what those grains are capable of. And again, you take that chart, I'll be happy to send it to anybody that wants it. Follow that chart. And again, I know we've been there, and believe me, we see situations where people do take more off than they should and get by with it. And sometimes that is a solution, because you know what, maybe you're losing a little bit of belt life, but you're still doing better than if you had to make 2 passes, you're losing time. But you just got to make sure your end result is what you're looking for. And the way we do it is we go in and we say, okay, what grit do you want to finish with? You don't start from the front, you start from the end. Well, I really want a 220 grit scratch. Okay, let's start with your last head and work our way back. That's going to tell us, because obviously if you want a 220, you got a 3-head machine. The most you could do is go from 220, go to 150, and then go to a 100 grit. That would be your grit sequence. And if you absolutely want a 220 grit sequence finish, scratch at the end, then and you can't do it with those 3 grits, you're really going to have to make another pass. Unfortunately, that's just the way it works out. Math is all that you got to really keep in mind when it comes to wide belt sanding. It is very critical. Let's see here. Apologize. See if we got another question here. Okay. And if I miss anybody's questions, I apologize. It's my first time doing this. I'm not the greatest at it. Looks like we got somebody here that's commented. Pardon me 1 second here. Okay. I think I should have my kid run this for me. Let's see. Okay. Here's some questions. I see a lot of 100, 120 grit at medium-sized shops on 2-head sanders. Is it not better to do 100, 150 and get a better finish that way. That is from Pascal, and absolutely, Pascal, you're exactly right. And this is one thing I'd like to say. A lot of people may have an older machine, maybe one head, and a lot of times they're just using that machine for calibration, for stock removal. Well, I got a one head machine, so I'm going to use a 80 grit and a 120, and then I'm going to hand sand everything. Man, my advice to you would be, it may not work, but say you do 180, 120 in cloth. Get a couple, sample of a 150, 180, and make another pass putting paper on there, maybe even cloth in 150, 180. Because keep in mind, anything you can do to reduce the amount of hand sanding you're doing is so much better. Hand sanding is where the costs are. I mean, that's a lot of time, a lot of effort, and now you're using an oil drill. You got more chance of making defects with swirl marks. We see it a lot where people are like, we just use that machine to calibrate. And I get it. Some machines you can't use paper on. Some machines just don't finish well, and I get it. At that point, what are you going to do? You got to do a lot of hand sanding. But don't give up on a small machine or an older machine. Give it a chance to do your finishing for you. It's much better to run it through that wide belt and let it give you a nice soft 180 grit scratch than to finish at 120 and spend all day long getting to your 180 or 220 grit scratch for the finish. So thank you for the question, Pascal. All right. Okay, sanding belt runs off the machine. This is almost always a tracking issue. Photo cells and sensors is too strong. The light is going through the belt. So especially on paper, what's happening is sometimes that light is set too high and it will cut right through the belt, so it's not able to see that belt is coming into the zone where it hits that sensor. The tracking cylinder is not working properly. It's not adjusted properly. We see this a lot. People don't realize it. That cylinder is not engaging. It's not getting all the way up. Maybe they've lost belt tension, or maybe it needs a new cylinder. So if you're not getting the right amount of tension, that can be just as bad as having too much. And it can cause that belt to track off. Improperly storage of the belt, again, if you store it on one end, it's going to swell, becomes like a cone shape, and it's almost impossible to get it to track and stay on the machine. Improperly made joint. I'm going to get to that in just a second. Here's the quick evaluation to do, especially with tape joints, because tracking is sort of like chatter. It's either coming from the belt, typically, or it's a machine issue. The machine issue could be the sensor. It could be a lot of things. But the way you quickly find out is if you have belt tape joints, especially, which we prefer to make. We certainly do lap. We like tape better. And I'll tell you one reason why too is when you run a lap joint. Okay, you're taping one end of or you're gluing one end of the belt over the other, right? So if it's like this, your direction needs to be that you need to be feeding to where this part of it is going through the machine. And because if you notice, that's the smooth part. If you do it like this, if you don't have the belt in the direction of the arrow it suggests, you see this piece here, it's liable to catch and pop that belt joint off. And even on our tape joints, we have arrows. You don't have to follow those on a tape joint. It's universal. You can flip it either way. We print the arrows at the factory because we don't know what kind of joint we're going to make with it until we make it. But on a lap joint, you need to follow those arrows. One reason we love tape joints and one reason we really push people to that is it's great if you got really, really sharp people in your shop. Unfortunately, it's not always the case. And it just kind of takes it helps people not, whether they make a mistake and put the belt on the wrong direction, then it doesn't matter. If you have somebody that really doesn't understand what they're doing and they put that lap joint on the wrong way, you run a much bigger risk of busting that belt. Tape is idiot free. It doesn't matter who puts it on there, which direction, it's going to run the same either way. But if you want to evaluate for tracking issues, here's a quick, simple way to do it. You take the belt and you put it on. So we're going to say that the side that you open the door on, we're going to call that the operator side. The other side is the motor side. So let's say you put that belt on, you fire your machine up, and off that belt goes to the operator side. Tracks right off, cut your machine off. Okay, take that belt out, flip it, put it back on, turn the machine back on. Now, the first time you did it, it went off the machine side. Now this time it comes back to the operator side. 90% of the time, that is because the belt is out of round. It's not been cut correctly. If you put it on, and the first time it went off on the machine side, and the second time it goes off on the machine side, you can almost bet your money that that's a machine issue. If a belt's cut out around, I don't care how you flip it, it's going to switch directions of which way it's coming off as soon as you flip it. Because what's happened there, one side of the belt is longer than the other, and it's just never going to track properly. And again, most companies that make belts make them in lots. If you order 10, they tend to make 10 at a time. They're not typically making a huge lot for an order. And unfortunately, most defects in a belt are going to be in every belt in the box. You could try another one, but I would almost guarantee you're going to see the same issue in most cases. It's not always that way, but most of the time that's what you're going to find. So don't get frustrated if it's like every belt in here is bad. You may open up a box, like on ours, we have manufacturing numbers, so you could actually see that it's from a different lot, and you'd be able to run that belt and it would probably run fine. So that's a quick way to check to see if it is a belt issue or if it's a machine issue. Okay, the standing belt's not oscillating smoothly. The tracking cylinder, the throttle valves are not properly adjusted or worn out. We've kind of covered a lot of this. The air pressure is too low. Those are things to check. Again, improper storage. I know a lot of this is redundant. And too low belt tension. I can't stress how much that belt tensions are critical. You don't want them too terribly tight. They can't be too low, but we always would err on the side of lowering the belt tension in most cases and not having it too tight. It really will help. It's not only good for your belt, it's not only good for helping your belts last longer, it's also better for your machine. If you think about it and you put a belt on and you've got it at 100 PSI and you can't even squeeze anything out of that, think how much it's wearing your rollers out. And I don't just mean your rubber roller on the bottom. You know, our tech is really good, and you'd be surprised how many times we go in and everybody's looking at that contact roller when Tony says, you know what, guys, your problem's not that contact roller, your problem's this idler roller. You don't think anything about it because it's not motor driven. It's just spinning. But that thing could be out of, you know, it can get worn out like anything else. You can even get chatter because of the idler roller when your drum is fine, because it may be up there bouncing. So, you know, it's very critical to look at every component on the machine and look at one problem first before you do any adjustments. You know, you don't want to go in and make adjustments on 2 or 3 different things because then you don't know what fixed it. Let's see if we got a question here. Okay. We are doing, this is from Anonymous attending. Well, thank you, Anonymous. We appreciate you being here. We are doing 100, 120, and then 150, 180 on our doors, and it started to leave a ripple effect. Feels smooth to the touch, but as soon as you put a layer of paint, you see it. Wow, that is a difficult one for sure. And if it's just suddenly started coming up, man, that's a tough question. we almost really want to be there to see that. 100 grit, 120. If anybody out there has any suggestions, let me know too. We're doing 100, 120, and then they're changing to 150, 180, which is perfect. It's an absolutely great grit sequence on our doors, and it's started to leave a ripple effect. I'm not really sure I'm understanding what the ripple is. Now, if you could snap a picture of that and send it to me, I could get our tech and myself and some of our other people to take a look at this. Feels smooth to the touch as soon as. Now, one question on that would be, here's what one suggestion I would have. If you remember, I was talking to you about the difference between cloth and paper. Cloth, like I said, it's always going to leave, if it looks kind of like a railroad track, like it's oscillating, and as I said, you'll never feel it, but you see it. What I would suggest, if the 150 and 180 is cloth, at least on your last head, try paper. That may solve that problem. Now, if you're already doing paper, then that's a whole nother issue. And we'd be happy. I'm not sure where you're at. You know, I've got all of our people grounded right now on our tech, and everybody's killing, you know, dying to get back out there. Unfortunately, we're not feeling comfortable yet with that. But if you let me know where you're at, our services, we don't charge for that. For instance, if we send our technician out to a part of the country, we just try to make sure he has plenty of machines to work on to make it cost effective. We'd be happy to come in and take a look at your issue. If you let me know where you're at, I could certainly look, you know, where you are and see if we can get some out to help you. But anyway, you know, please send me an email. We'll help any way we can. But I would look at paper on that if you're running all cloth. So I know this thing's getting long. I think we're going to finish it up here. The machine gets dusty. Look at your dust extraction. Static issues cause that. Again, if you ground your machine, it helps a lot. Use anti-static belts. That's very important to help with that. And I appreciate everybody. I'm sorry if it ran a little long. I went as fast as I could. Again, reach out to me at curtishicks@uneeda.com. I'll put you in touch with a machine technician or a sales engineer to help you. And you know, I hope everybody's safe, and I hope that soon we can all see each other again face to face. Thank you so much for joining the webinar. Thank you.